thyroid cartilage, that little pokey thing is the Adam's apple, so to speak, the laryngeal prominence, so to kind of get oriented. Not a whole lot is visible except for the lungs. What we can see, basically what I'm holding here now is the larynx, and you kind of notice that thyroid cartilage, but it's still wrapped up a lot. You don't see too much. You kind of see the thyroid cartilage and the laryngeal prominence. Then here's the trachea. You can see those tracheal rings, kind of like you see a ribbed appearance, and if you rub your finger, you can feel them as well. So there's the tracheal rings. They go by a number of names: cartilage rings, C rings. I can't even remember all the names, but the newer one is tracheal ring. I think the blue sheet uses the word C ring a lot, or maybe cartilage ring. It's still acceptable, but I guess maybe we should move on to tracheal ring. It seems to make sense. So anyway, we see the larynx here, the trachea, and the tracheal rings. But this specimen mainly, as you see, shows the lungs. So here is the left lung, has two lobes. The left lung smaller, right lung is bigger. Anybody know why? Why is the left lung smaller?
Space for the heart.
Space for the heart. That's correct. So two lobes here. It looks like the front lobe and the back lobe, but the front lobe is really superior. It is a little bit. It's kind of up here at the apex of the lung is mainly this lobe. So this is the superior lobe. Behind it and apparently under it is the inferior lobe. And when you look at the base of the lung, the bottom part, you see most of it is this lobe here. This smooth surface here is where the diaphragm would be. It's not here right now, but the diaphragm would be, under the lungs and pulls the lungs and pushes them and makes you breathe. Over here on the right lung, we have three lobes. The right lung is bigger, so you have the superior lobe here, the middle lobe, superior, middle, and then inferior here. And when you look at the base of the lung, most of it's this lobe, so that's kind of what you go by. It's not like they're stacked on top of each other, superior, middle, inferior. They're kind of on a diagonal, etc. So superior, middle one's a little smaller, inferior is pretty big and kind of makes up the base of the lung. Okay, so that's about all we can see on this specimen. I have a couple more to show you more things on the list, but that's coming up now. A cardiac notch, and I'm going by memory on the Roman numeral 3 on the blue sheet. That was where the specimens were. So these flat surfaces that are kind of looking at you, not you, but you, they, again, the diaphragm would be kind of connected. But look at this one. This is the cardiac notch. This surface in here is where the heart would be. So this concavity or this space, put my fist in it, is that the fist or the heart, okay? So my fist is in the cardiac notch. So I'm gonna move it out so you can see it. Ta-da, there's the cardiac notch. It's only on the left lung, not on the right. The heart is over on the left side. That's where the heart would be. There's one other thing that we can see on this specimen. There's the most things to see. So what we're looking at here is, to kind of get you oriented, is we have a trachea and an esophagus. So the trachea is in front here, shorter. The esophagus is in back, and that's longer. And what you're looking at right up on top here is the back of the tongue. Okay, so you can kind of see that. Here's the lingual papilla, where the taste buds are here at the, the posterior aspect of the tongue, right as it's going down, into the throat. It looks like the tongue is kind of been cut. You've got the tongue here, and what's been cut open here to kind of reveal the openings into the trachea and into the esophagus. This area that's been cut is the pharynx. Okay, so there's the tongue pointing out this way, and so this would be the back of the throat, or the pharynx. So the pharynx has been cut open. So this area here that's been cut open is the pharynx. If you look, I'm going to put the probe now in the glottis, which is the opening into the trachea. Okay, so I don't know if glottis is on the list. I think glottis is on one of the models. I don't think it's here. But so the trachea is this tube here that I'm pulling on. and the probe is in that opening, going down. The probe is going down in the trachea, like this person's choking on that probe. Now I'm going to put the probe in the esophagus opening. Okay, so that's where the food would go. Notice there's two openings there. And again, I don't know if you need to know the openings, but just so we can get oriented on the specimen. Okay, so there's the esophagus and the trachea. Now this little thing that's curling up, like a diving board or something, that's the epiglottis. This thing that I'm pushing down, it looks a little like a tongue itself, a little mini tongue, facing the wrong way, but anyway, this is the epiglottis. So when food comes down, when this person who's now looking at me swallows the food, like say it's a hot dog or a sausage, it comes down, it pushes on that epiglottis, and the epiglottis covers the glottis, which is the opening to the windpipe. Like a little garbage can lid, it closes down over the opening, so the food, which is my finger, goes over the windpipe and down into the esophagus, which is behind it. So food's coming in from the front, but it has to get over the windpipe to the food pipe behind it, so the epiglottis, literally the food itself, as it's being swallowed, pushes the epiglottis closed, covers the top of the larynx, the opening to the windpipe, so the food doesn't go down there. And then the food goes down the next pipe behind it, which is the esophagus. So a little explanation there, mainly highlighting this wonderful little structure here, the epiglottis, which you might remember is made out of elastic cartilage. Elastic cartilage, same type as your auricle of your ear. Alrighty, so that's kind of the top part of this specimen. Then getting more to the business end of things. Here's some things, a list of structures on that blue sheet. So starting at the top here, at the crook of the neck, this is the hyoid bone. Listen. Okay, it looks a little like a jaw or a lower jaw kind of. This is the hyoid bone. Not to be confused with the neck structure below it, looks like a shield or something. This is the thyroid cartilage, officially part of the larynx. So the hyoid bone really is not part of the larynx. That's at the crook of the neck here. Down below around your Adam's apple, that bulgy thing in your neck. That's the laryngeal prominence of the thyroid cartilage. I don't think laryngeal prominence is on Roman numeral 3. You have to know it on the models or something. And you probably should know it here. It's just this pokey thing, a pokey portion of the thyroid cartilage. Moving our way down the larynx, still in the larynx, just beneath the thyroid cartilage is a softer portion. This is the cricothyroid ligament, and there's the cricoid cartilage. So it's a little subtle. Again, you might have to reposition yourself. So you got a big shield-like thyroid cartilage with the laryngeal prominence. Then an area of softer tissue. See, the probe is poking in. This is the cricothyroid ligament. And then harder tissue again. Looks a little like a smile down here. That's the cricoid cartilage. Then trachea. The larynx itself are these cartilages and the ligament between them. Then when you get below the cricoid cartilage, you begin trachea problem. You saw the trachea on a previous specimen, and it's a little cut up here, but I'll leave these available for you. I advise you to maybe review them before you leave today, and you can kind of feel them a little, grab some gloves, you can feel those cartilage rings, the tracheal rings in the trachea. Anybody know what this is called, where the trachea ends and it splits? What's this kind of crotch here, this bifurcation? What's that called? The carina. And what does the trachea bifurcate into? What are these two things? Primary bronchi. There you go. Bronchus would be singular, bronchi is plural. You may notice that they're asymmetrical. Does anybody know which one? It's a little hard to tell here, but you might just know in theory. Which one is bigger? The right primary bronchi or the left?
Right.
The right. And why is that?
Because it doesn't have the heart of it.
Yeah, well, the right lung is bigger.
Yeah, because it doesn't.
And then it comes down to the heart again. You might notice the angle. Which one goes more straight down and which one cuts more to the side? Which one goes more straight down, the right or the left?
Right is straighter?
Yeah, the right goes more straight down, if you notice. And why do you think the left cuts off to the left a little sharper?
Because of the cardiac notch.
Because of the heart, cardiac notch, the heart's there. So you might notice the right one kind of goes more straight down, the left one cuts to the side because the heart would be here and it can't go straight down. So which one do you think people choke on more, where food gets caught more in the, if it really gets way down there, in the right or the left? What do you think, on average, would more people get choked up on food would go in which one?
The left. The left because of the curve?
You always get a mixed bag, so which one's bigger and which one's more straight down?
Oh, the right.
The right, yeah. So it's, first of all, it's bigger, and the food will probably go straight down as opposed to cutting a sharper angle to the left. So that's not on the practical, but it's a little thing of interest that more people get, food stuck. That's pretty bad. If it gets all the way down there, that person's choking pretty hard. But anyway, just a couple of observations about the asymmetry of the bronchi. So let's review real quick. Pharynx was the opening that's been cut, kind of the back of the throat. The epiglottis is that springboard looking thing. The glottis is the opening that it covers, the opening into the larynx, the opening into the windpipe, so to speak. The tongue, it's kind of easy, it's kind of cut, but here's the surface of the back of the tongue with those lingual papillae. Trachea, carina, esophagus, and C-rings. So trachea, the windpipe. The carina is where it splits. Esophagus is the mushier tube behind it. It's longer. Oh, the C-rings, which I prefer tracheal ring. It just seems better. C is okay. Thyroid cartilage, cricoid cartilage, hyoid bone, trachealis muscle. Okay, so we didn't see that one yet. So here's the hyoid bone. And the thyroid and cricoid cartilages, and the ligament in between, the cricothyroid ligament. So you know the name stands for crico from the cricoid cartilage, thyroid, cricothyroid to the thyroid cartilage. So the name of the ligament is because it connects the two cartilages. It's kind of straightforward. The trachealis muscle is in the back of the trachea. So here's the trachea, and these rings are indeed C rings. And I don't think the C stands for cartilage ring. I think it's because it's shaped like the letter C, like this. So in the back is the opening, like a horseshoe. In the back is the opening, and the trachealis muscle connects the two tips of the C, or the two ends of the horseshoe. And we'll flip that over and show you. So the C rings are going around the front, but when you flip it over and look at the back, you see this area here, see the ring ends here and the other end here, but this mushy part is the trachealis muscle. The diaphragm, no, we won't see a diaphragm. It's a big muscle. You'll see it next unit when we go into the abdominal cavity on a cadaver, but no diaphragm here. Primary bronchi, we saw those two, the right and the left primary bronchi. A portion, they're not long. Once they split, which isn't too much further, they'd be secondary bronchi. But they're primary here, but they're just stumps. Okay, so thank you.
So I have a quick question. So on the exam, if by chance you ask about the primary bronchi, you're talking about the stubs, right?
These
Not
from
the
here,
actual.
from the carina to this end.
Yeah.
So that's the right, and that's the left.
Okay.
Primary bronchi. Bronchial tree is on this other specimen, which we'll look at right now. This is a right lung. How do I know it's a right lung? Three lobes. So this is also, we saw the other lungs, but I could also ask you this one because we're seeing this one too. Now the bronchial tree, of course, is the primary, then they split the secondary, then they split the tertiary, and then they go to bronchioles. So we're just going to kind of collectively call all of these tubules the bronchial tree. I don't know, there's a primary one and there's some secondary ones. Now what might be mixed up in there is the pulmonary vessels, the blood vessels as well. So that's not all bronchial stuff. I'm sure there's, the air has to come into the lungs and the blood has to come into the lungs. So picture two trees just kind of penetrating deep into the lungs, the blood vessels and the air passageways, because they have to intermingle. You got to get that air, the oxygen into the blood and the carbon dioxide out of the blood. So they're both penetrating in there. But let's just say that most of these tubes, for the sake of our purposes today in this unit, these tubes are the bronchial tree. These don't say primary bronchi, secondary. I don't know how you could tell. Well, maybe you could find the primary ones.
Is that
This is the primary here. These are blood vessels.
of the lungs
Here's the
that have
primary
the
bronchus, I think, and then it instantly splits and splits and splits. So we'll just call this whole thing the bronchial tree. And then we have the lobes of the lungs and the cardiac notch. We don't have a cardiac notch on this specimen because it's a right lung. Cardiac notch only on the left lung. Okay, so I think we do everything on the list except for diaphragm. Except for diaphragm.
Now, would you ask about the diaphragm on the lung specimen?
Well, the diaphragm is part of theory when we talk about the breathing muscles and, you know, contracting and relaxing, and there's a fair amount of that. The pressure and the volume relationships with the diaphragm is a major player in that, you know, physiology. You won't be tested on it on these specimens. Is it on the torso models? Is it
It's on the respiratory model.
what was that?
It's part of Roman numeral 2.
Oh, it is
For
there,
the
okay.
respiratory models.
Okay, so it is on the models. I assume the torso, because I don't think the diaphragm would be on any of those other models. So the torso would have a diaphragm. So you wouldn't be
So
tested.
we would
That's a
for
fair-
the models.
Yeah, on the model, which is Roman numeral 2.
Two.
But as far as Roman numeral 3, we don't have any specimens. If we took you to the cadaver really doesn't show anything beyond what I've shown you here today. So, given our time constraints, we still have to do slides and make little models. We just didn't quite work that cadaver out because of our shy day because of Labor Day and stuff. One less lab day this time around. Well, this because the break was next week.
And you can't push that back, no. You can't push it back at all.
I could push it back, but then you'll be sorry later. You won't have enough time for